All right, everybody, this is 2.2. We're going to be talking about polynomial properties again. We're going to add what we did from last time. We're going to add end behavior and y-intercept. So both of these things you should be familiar with. We talked about those in secondary math 2 when we did quadratics. Okay, so just a quick reminder of end behavior. So if we were to fill in this table, again, we could either use the graph or we could use the equation for the graph. It would just be the parent graph of x squared. So if we plug in these values, we would end up getting something like this. Again, it's symmetric on both sides, as it should be for a parabola. And then let's talk about end behavior. So end behavior is just saying as you're going really far in this direction, which is like going towards infinity, what happens in, like, what direction are these arrows going? Okay, are they going up to infinity or are they going down to negative infinity? Okay, so looking at this example, it looks like the arrows are going both up to infinity. So as you go to positive infinity in the x, the y goes to positive infinity. And if we go to the left, or negative infinity, the arrows end up going to positive infinity. Okay, so remember doing that? Okay, some people use the words like, as it goes to the left, it goes up. As it goes to the right, it goes up. Like the arrows are going left and up and right and up. Okay, that's where the arrows are heading, if that's helpful. Okay, we're going to use, gosh, now the word is missing me. What's it called? Formal. Yes, we're going to do formal end behavior. Okay, so formal behavior, last year when we talked about it, it looked something like this. Again, it's saying the same thing. As x goes to negative infinity, y is going to infinity because the arrow is going up. And if we go to the opposite direction, I guess that was this side. As we go to positive infinity in the x, the y is also going up to infinity. Okay. Today we're going to be focusing more on writing it this way in what's called limit notation. The limit is just saying as x goes to negative infinity, what's happening to this function? And for this example, it's going to infinity. And as we go to the positive infinity, as the limit of x goes to infinity, the function f of x goes to infinity. Okay, so it's all kind of the same. We could say it is up, up for like positive infinities. Okay, if the arrow was going down, then we could say it's going down and down, or negative infinity in both of these situations. Okay, so we're always going to check to the left. We're always going to check to the right. So that's like the x's going left or right. Where are the y's headed on that graph? Okay. There is this Desmos thing that I came up with to kind of explore some of this information. Just to save time, I'm going to have these already kind of sketched below. But I think it's helpful to kind of maybe go look at that and give that a try. I have it also on our Canvas course, so if you want a live link to click on rather than trying to type this all in. Okay. So anyways, when you go to this, we kind of explore what happens when we change the exponent on that graph. So this is a linear equation. It should look like a straight line. Okay. And as we change these, we're changing it from 1 to below where it's 2, then 3, then 4, and just seeing what happens with the degree. Okay. And how that affects the end behavior. So let's write down the end behaviors for these. Again, this is kind of like our old notation. Again, on your homework, it's going to be written in limit notation, which is going to look a little different. Okay, but we'll do some more examples of that in just a little bit. Okay, so again, this is saying as you go to the left, what direction is the arrows going? Well, it's going down. So this would go to negative infinity. And as you go to the right, it goes up. So that would be positive infinity in the y direction. Okay? And we're just going to go and fill all this in. So if it's x to the third, it looks like these are all going the same direction. So to the left, it's going down. And to the right on that graph, it's going up. And this will happen for all of these when the degree is odd. Now let's look at the quadratic below. So both of these are going up and up. So infinity to an infinity. And all of these look very similar. I did my best to draw it. But kind of what happens is when the degree gets higher and higher, it gets more like slat on the bottom. Well, that just went really weird. Okay, so it's very similar. It just gets more wide and kind of flat. So all of these are going in the y direction, are going up and up to infinity and infinity. Okay, so what do you notice about the degrees and the end behavior? So if the exponents are odd, if it's odd degree, then we end up getting it goes, what did I write here before? I was writing down and then up. So to the left it goes down, to the right it goes up. Maybe we should just write it in limit notation. Good practice. Okay. So here we'd have the limit as x goes to negative infinity, so that's going to the left. The function f of x goes to negative infinity. And then as the limit goes from x to infinity, so going to the right, the function goes to positive infinity. So that's kind of what we got on the first row. Okay, the left goes down, the right end goes up. Okay, and if it's even, then they all go up. So we could kind of just copy this whole same thing. Just copy that. You can't really do that. Sorry. Okay, but both of them, of the sides, the left and right, both go up and up. Okay. All right, so that's kind of interesting. And then let's talk about, so if you go back to that Desmos thing, then you can change the leading term versus positive or negative. So here the thing that changes here is it changes all of the signs. So if it was an even degree, which goes up and up, or infinity and infinity, when a is negative, then it's going to make it go down and down, or negative infinity and negative infinity. If it's an odd degree, again, normally it goes from down and then up. It's going to swap it, and it's going to go from up to down. So infinity and then negative infinity. I hope that's kind of making sense. If you have questions, please let me know. Okay, come in. How does that doesn't make sense. How does I think it's supposed to be leading. A leading negative change the end behavior. So it flips the behavior, okay? Okay, so if it went up and up for the even degrees, then it's going to go negative, down, down for negative infinity and negative infinity. If it was positive positive degree, it was going negative to positive infinities. Now it's going to go from infinity to negative infinity. Okay, so the directions all swap. And then the last thing I wanted to look at is what happens, because all of these examples are all monomials. They just have just one term. What happens if you add other terms? Okay, so if you can go there and try that, really what you're going to end up finding is that the leading term controls the end behavior. So it doesn't matter what else you add. You could do x to the 8th, or if you had x to the 8th plus 1,000, x to the 7th plus 10, x to the 6th minus 7x, okay, you would still have the same exact end behavior. What's kind of going between those two, the ends, will look a lot different, okay? You're going to have different x-intercepts and maybe complex solutions and all that kind of stuff, but the end behavior is going to be exactly the same. So for this one, this example would go up and up, or in this notation, okay? I guess I probably pointed at the wrong one, so it would probably be like this one, okay? All right, so let's kind of bring that all together down here, okay? So again, end behavior, when you're asked to label the end behavior, ask yourself the following two questions. What happens to the y values as the x values get more and more negative, or to the left, right, on the graph? And then what happens to the y values as the x values get bigger and bigger? So like the right side of your graph as you get closer to infinity, okay? So kind of bringing this all together, if we have a positive leading term, so just here's some examples, okay, and it has an even degree, then it's going to go up and up. Those would be the end behaviors. Again, when we talk about this in the formal sense, we would write it in limit notation. So that's what you're going to see on your test is going to be that limit notation, okay? If we have a positive leading term and it's a an odd degree, then it's going to go down and then up, or negative infinity to infinity, okay? One thing you kind of think about is that, like, no matter what you have going on, like if we had it like this, okay, it's basically going to be the same as if it were like a linear, right? So whether it be a x to the 1, like a linear equation, or x to the 3, or x to the 5, it's still going to, like, generically over the long run of your graph, it's going to be like, you can kind of think of it as a positive slope, okay, like a linear equation, okay? I don't know if that helped, but, okay, and then if we switch it, if the leading term is negative, then instead of going up and up, it's going to go down and down, okay, kind of like a parabola that's facing down. Those are both going down and down, okay, so negative infinity and negative infinity. And then if we do like an odd degree, again, it was like this. Now it's going to flip underneath, or reflect it. So it's going to be up and then down. So positive and then negative infinity. Okay, let's do a couple examples really quick. So the first part, this is probably the hardest part for today, but it's good to have more practice about, or coming up with the leading term, because this is all about the leading term, right? So here is our leading term. It's our highest degree, highest exponent, okay? So it's a positive coefficient and an even root. So again, think of it kind of like, if it's even, it's kind of like a quadratic. So I'm just going to draw a positive quadratic, okay? So this is going to go up and up, so infinity and infinity. If we look at the second example, this is a little tricky on you. Again, we have two that have the same degree. That means we can combine those. So that would just give us 1x to the 5th. So it's an positive odd. So again, if you're thinking of positive, that's like a linear equation that has a positive slope. So it's going to go from negative infinity to positive infinity. Okay? All right. And then now these are in standard form, so we need to find the leading term. So again, we multiply the highest, the higher terms in each factor. So we need to multiply negative 4x times x squared, so that's from here, and then times x to the third. Okay, so I think that's just negative 4x to the sixth would be our leading term. So it's even, so again that's like a quadratic, and it is, a is negative, the leading term is negative, so it's going to open down. So we're going to have negative infinity would be the directions in the y direction. Okay. Last one more. 3x squared, so that's one of our terms. We need to do the 2x to the fifth, right? And then we've got x to the fourth. So 2 to the fifth, again, probably need to use a calculator, but we've got 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Oops, I already did that part. Okay. Hopefully I didn't mess that up. Okay. And then we need to multiply that by 3. So that's what, 96? So 96. Again, the number doesn't care so much, it's the sign. So if just looking at it, realizing that when you multiply those, you're going to get a positive, that's what really matters. Okay. And then with the variables, that's kind of important to know what the degree is. So 2 plus 5 plus 2. So that should give us x to the 11th. Okay, so it's odd, like a linear equation, and it's positive slope. Okay, positive leading coefficient. So we're going to go from negative infinity in the y direction, and on as we go to the right, it's going to go to positive infinity. Okay, so here's just a couple more examples. We already have the end behavior. So again, this one's a negative quadratic, so it's going to go like this. So negative infinity, negative infinity. Well, let's go down, I guess. Okay, this is positive, and it's still an even, so it's going to be like a quadratic. So it would be positive infinity and positive infinity. This is an odd, so it's like kind of like a linear, right? And it has a negative slope, so it's more like this. Again, I say it's like a linear, and though it's a cubic, but they have the same end behavior, so all odds kind of have the same, right? So we would have infinity and negative infinity going from left to right. All right, here's this down, like negative, and it's even, so it's like a quadratic going down, so negative infinity, negative infinity. This one's a positive linear, so it's going to look like this. So negative infinity to the left and positive infinity to the right. And then again, this is odd, so we can treat it like it's a linear, has the same end behavior, and it has a positive slope. This would be like a positive 1. So it will be the exact same end behavior. Okay. All right, I hope that makes sense. Let me know if you have any other questions. Last thing we need to talk about is y-intercept. So it's very similar to like finding your leading term. Okay. In standard form, it's just your constant. Like if you were to plug in, or you want to find your y-intercept, we know that the x has got to be 0. So we could set each of these x to zeros, and this would all go away except for the 5. So if you have it in standard form, it's always going to be your constant. So if we look at b, there is no constant, so it must be a 0. So our y-intercept would be 0, 0. Okay, and this is where it gets a little more complicated, just like when we were trying to find the leading term. Okay, but again, we're just setting x equal to 0. So really what we're multiplying is negative 4 times 2 squared times negative 3. And you can put that all into your calculator if you wanted to. It's going to try and simplify this a little bit. So this is going to give us a positive because we have two negatives. This will be 12 times 4 is 48, okay? And then I guess I probably should write as an ordered pair. Okay, let's try one more like that, okay? So again, we just set these terms to be, or these x's to be zeros, which means this 2 is gone. And this is also 0. So we've got 3 times 0 times 1 to the 5th times negative 2 to the 3rd. Oh, but if you multiply something by 0, that means the whole thing is 0. So we'd get 0, 0. So watch out for that. If you have an x that's not in like a parenthesis, then it's going to make everything be 0 if x is 0. All right, so that's pretty much it. We're going to put do a couple of these examples, and then we'll be all done. I'd maybe ask you to maybe pause at least for one of these and see how you feel before you get onto your homework. Okay, so leading term. We've talked about this. Leading term, we just find the leading term for each factor. So negative x times 3x squared times x. So this will give us 9x squared. And we'd get negative 9 x to the 4th. So that's our degree. Or sorry, not our degree, our leading term. Sorry, it's been a long day. Degree is 4. Number of roots is the same. It's also 4. Again, they could be real or complex. Max number of turning points. Again, that's just 4 minus 1. So the degree minus 1 is 3. Okay, the y-intercept. So now we need to look at this. Maybe I'll do a different color for that. Again, this is going to be negative 0 times, but if you have 0 times anything, it means the whole thing is 0. So this would be 0, 0. And then let's talk about end behavior. So since we have a negative, and then we have an even degree, so that's going to be kind of like a quadratic. So it's going to be facing down. So our behavior, again, we're going to write this out in limit notation. On your homework, you won't have to write it because it will be there. You're just kind of filling in the blanks, but I think it's good to practice. So here we have, it's going to go down, down, and down. So if we do limit as x goes to negative infinity, f of x goes to negative infinity. So it's going down. And as you go to the right, so the limit as x goes to, sorry, I should zoom in for you here. As x goes to positive infinity, f of x goes towards negative infinity. So they both go down and down. So this is our down and down. Okay? All right, and then we have our factors. Okay, just be aware that on your homework for these, again, they don't write the exponents in the table. So this is like an x to the 1. This is an x, or this one's 2, and this is a 1. So this is just, you have to look at the equation at the top. So zeros, again, if you set these equal to 0, we would get 0. If we set this equal to 0, then we'd have to add 2 and divide 3. So we'd end up getting 2/3. And then we'd set this equal to 0. We'd have to subtract 3. So we'd get x equals negative 3. Our x-intercepts would have 0, 0, 2/3, 0, and negative 3, 0. Multiplicities, again, the multiplicity is basically the exponent. So we see the 0 one time, we see the 2/3, 0, it shows up twice, and this would happen one time. And then intercept behavior, again, if it's odd, or if the multiplicity, like the degree or the multiplicity, or I could say the exponent, again, if those are odd, and then it's going to cross. If it's even, I guess we write that here, cross, and if it's even, then we would end up bounce. So we have cross, bounce, bounce, cross. Okay. All right, let's do one more example. Okay, so this one we want to find the leading term. Again, we'd have 2 for this times x squared, and then times 2x to the third. Now don't forget to put a parenthesis around that, otherwise you might not cube the 2. So this will end up giving us 8x to the third. Okay. All right, and then we'll multiply the rest of the way. We'd get 16x to the 5th. So 16x to the 5th. So we have a degree of 5. Roots is 5. Turning points, again, is 5 minus 1 is 4. The y-intercept, so I have to watch this one again. It's kind of new. So again, we just end up putting zeros in for our x's. So we'd end up getting 2 times 3 squared times, again, this is going to be gone, so just 1 to the third. And 2 squared is 9, so 18. So 18, comma 0. And behavior, again, we're looking at the leading term, so it's positive, odd. So that's kind of like this. A linear equation kind of going positive slope. So we'd go from, I guess I should write this over here. It's going to go down and then up. So the limit as x goes to negative infinity, so we go to the left, the function is going to negative infinity, that's our down. And then as the limit as x goes towards positive infinity, the function goes towards positive infinity, so that's our up. All right, almost there. The zeros, again, watch out for the exponents. This is going to be, oops, this is, oh, I think I messed this up here, didn't I? Oh, yeah, I messed this up. This is supposed to be a 3. Okay. So this one's a squared term, and this is a cubed term. So our zeros would give us -3 and -1/2. X-intercepts would be -3, comma 0 and -1/2, comma 0. Multiplicity is 2 and 3. And then intercept behavior, again, if it's even, it's going to bounce. And if it's odd, it's going to cross. Okay, so that's it for today. Please let me know if you have any questions. I'm happy to help you out if you need. Okay, we'll see you later.